Welcome to section 7.1, Simplifying Rational Expressions. A rational expression is an expression of the form P over Q, where P and Q are polynomials, with Q not identically zero. We say that a rational expression is defined for a particular number if the number does not make the denominator zero. When we ask where a rational expression is defined, we determine where the denominator is zero, and then those are the values that get excluded from the set of real numbers. For example, suppose we are asked to determine the value or values for which the rational expression is defined. Our expression is 9 divided by x squared plus 4x minus 5. The idea is to find where the denominator is zero. The expression will then be defined for all real numbers except the ones that make the denominator zero. Finding where the denominator is zero means that we solve x squared plus 4x minus 5 equal to 0. Now we employ all of our factoring tricks. In this case, we are able to factor by inspection. We find factors of -5 that add up to +4, so that we see that it factors as quantity x minus 1 times quantity x plus 5. Using the zero factor property, we then set each factor equal to 0. This gives us x minus 1 is equal to 0, or x plus 5 is equal to 0. Solving x minus 1 is equal to 0 means that x is equal to 1. Solving x plus 5 is equal to 0 gives us x equal to -5. These are exactly the real numbers which we must exclude, so the rational expression will be defined for all x such that x is not equal to -5 or 1. Before we turn to simplifying rational expressions, let's remember simplifying fractions. Recall that when simplifying fractions, we take out common factors, numerator and denominator. For example, if we were asked to simplify 42 divided by 48, we notice that we have a common factor of 6 in the numerator and the denominator, so that 42 factors as 6 times 7, 48 factors as 6 times 8. Canceling the common factors of 6, numerator, denominator, leaves us with the simplified fraction 7/8. Simplifying rational expressions are exactly like simplifying fractions. We factor the numerator and the denominator, and we cancel common factors. The difference being at this point, now we are able to employ all the rules and algorithms for factoring that we have seen up to this point. So for example, suppose we wish to simplify quantity 5r squared s cubed raised to the second divided by 3r to the fourth s raised to the third power. Recalling your rules of exponents, we have a product to a power, numerator and denominator, so that distributes to each term in the product. Then we have a power to a power, so that we multiply exponents. Again, power to a power, we multiply exponents. This gives us 25r to the fourth, s to the sixth, divided by 27 r to the 12th, s to the third. Canceling common factors of r and s, numerator, denominator, leaves us with 25s cubed in the numerator divided by 27r to the 8th in the denominator. Suppose we are asked to simplify 4x squared minus 12x minus 40 divided by 2x squared minus 16x plus 30. We factor out the GCFs in the numerator and denominator. This gives us A factor of 4 in the numerator we can remove, and a factor of 2 in the denominator we can remove. So that we have 4 times the quantity x squared minus 3x minus 10 divided by 2 times the quantity x squared minus 8x plus 15. Canceling the 2's means that we are now able to factor the quadratics. X squared minus 3x minus 10. We find factors of negative 10 that add to 3, or add to negative 3. So this gives us factors quantity, or 2 times the quantity x minus 5 times x plus 2. Factoring x squared minus 8x plus 15, we have factors of 15 that add together to give negative 8. This gives us roots x minus 5 times x minus 3. Canceling common factors of x minus 5 gives us the quantity 2 times x plus 2 divided by x minus 3. Therefore, for our final answer, we have 4x squared minus 12x minus 40 divided by 2x squared minus 16x plus 30 is equal to 2 times the quantity x plus 2 divided by x minus 3. As our final example, suppose we are asked to simplify 6t squared minus 7t minus 5 over 3t minus 5. Factoring the quadratic, 6t squared minus 7t minus 5 gives us quantity 3t minus 5 times quantity 2t plus 1. Again, if you don't see this by inspection, you always have the quadratic formula to be able to factor this polynomial. Now we are able to cancel common terms, numerator and denominator. So our quantity 3t minus 5 cancels, leaving us with a final answer of 2t plus 1. Suppose now that we are asked to simplify 3k squared plus 6kr minus 9r squared over k squared plus 5kr plus 6r squared. We begin by factoring the quadratics. Factoring 3k squared plus 6kr minus 9r squared, we notice that we have a common factor of 3, giving us 3 times k squared plus 2kr minus 3r squared. Again, either using the quadratic formula or inspection, we see that this factors as 3 times the quantity k plus 3r, k minus r. For the polynomial in the denominator, we have k squared plus 5kr plus 6r squared. Again, either using the quadratic formula method or inspection, we see that this will factor as k plus 2r times the quantity k plus 3r. Now we're able to cancel common terms, numerator and denominator. This gives us a factor of k plus 3r that cancels numerator and denominator, so that our final answer is 3 times the quantity k minus r divided by the quantity k plus 2r.